In our previous video, we looked at calculating molarity as a way to determine concentrations of solutions. In this video, we're going to look at what happens if you already have a solution and you dilute that solution in water to make it less concentrated. How do you determine what that new concentration will be? And this particular type of calculation is called a dilution calculation. And essentially, how this works is, say you have a solution in a beaker and you have 1.0 molar solution of nitric acid, and then you happen to have, say, 500 milliliters of it. Well, if you add 500 more milliliters of water, your volume increases by double, but that also decreases your concentration of the solute versus the solution as a whole. And since you're doubling the volume, you're going to cut in half the concentration. So there is a mathematical expression that can help you solve that kind of problem, to where your new solution, instead of being 500 mils, is now 1,000 milliliters. You will cut that concentration in half to 0.5. So how do you solve that in an expression? Well, it turns out the way that we figure that out is we start with the concentration of our original solution that we'll call 1, concentration of solution 1, and the volume of our solution 1. And we set that equal to the concentration of the solution 2 times the volume of solution 2. And what this does is this essentially separates. This is your original concentration and volume of your solution, and this is now the diluted solution, its new concentration and volume. Because the same amount of moles of the solute is in the solution of the original and dilute, you can set these guys equal to one another. So when we're doing a solution problem, it is essentially as easy as using this simple formula to do a calculation. So let's try an example of that, where we're going to look at problem number 1, and it says, what is the molarity of the diluted solution when diluted to the final volume? And so your original solution says that you have 1 liter, 1.00 liters of a 0.250 molar solution of iron 3 nitrate. And then it's diluted to a final volume of 2.00 liters. And so to calculate this, we would start with our formula, C1V1 equals C2V2. And we assign numbers to these variables. So these two are of our original solution, so we will call those C1 and V1. So we'll plug those into those variables. So the concentration is 0.250 molar, that's C1. The volume is 1.00 liters, that's V1. And the problem asked to calculate the molarity. So we don't actually know what C2 is. We're just going to plus that as a variable in the expression. And the volume of your diluted solution, this guy right here, is 2.00 liters. So all we have to do now that we have everything plugged in is just solve for C2. And to do that, we just divide both sides by 2.00 liters. Our liters will cancel out, and this leaves us with molar or molarity as the unit of our final value. And that means C2 is equal to a value of 0.125 molar. And so our new concentration of our diluted solution of iron 3 nitrate is 0.125 molar. So a pretty simple problem here. Let's try one more. Problem 2 says if a 0.1718 liter solution of a 0.3556 molar solution of C3H7OH is diluted to a concentration of 0.1222 molar, what is the volume of the resulting solution? So this time, instead of solving for the unknown concentration of the new solution, we're solving for the unknown volume of the solution. And so we're still going to use our same formula, C1V1 equals C2V2. And what we need to do is assign our original values of concentration and volume. So these guys are going to be our original C1s and V1s. And then this will be our C2. So we just plug in and solve for our unknown. So C1 is 0.3556 molar. V1 is 0.1718 liters. Our C2 is 0.1222 molar. And our V2 is unknown. So we're going to solve for V2 by dividing both sides by the new concentration. Molarity cancels out, and this leaves us with liters. And the volume of our new solution will be a volume of, at 4 sig figs, 0.4999 liters. So that is our answer. The neat thing about dilution problems that is a little different than calculating molarity of a solution when you're using moles and volume and grams and those kinds of things is that because of how this formula is set up, you can really use any type of volume unit. So you don't have to use liters. You could use milliliters also, because they're going to cancel each other out whenever you're moving them from one side to the formula to another. So that's kind of a neat thing, but we don't have to use liters. You could use milliliters as long as they're the same on both sides. So those are 2 examples of how to do dilution calculations, and they're pretty simple, so I'm only going to show you 2. I will see you in class next week, and have a good weekend.